Okay. So the Shapeoko 4, this is a machine we've been talking about. Roughly 32 by 32 is our X and our Y. And then Z height is around 4 to 6 inches, depending on what bit you're using. That's another thing you got to think about. The length of the bit is going to change where it can start from. Like if you got a really long bit, you can take that thing all the way to the top, and it's still maybe limiting your.
Do you have to readjust zero when you change bits?
So that's a good question. Normally you would. Every time you change a bit, since they're different lengths, you would have to do that. We installed a little, they call it a bit zero. I think it's called bit zero. So it will automatically do that. When you change the bit out, it's going to run it over, it's going to run the bit down, and it's going to measure it automatically. Number one mistake, we've all done it, is that you have to turn the router off before it does this, because it just drills a hole in our sensor. It does it everybody does it. It's not a big deal, but okay. So what I'm going to do is let's continue where we left off here. Everybody can see okay? Okay. The Carbide Motion software. This is the software that controls the machine. It's actually wired to the machine. You load the file that you created into this software, and then it spits it into the machine. The other thing you want to do with this is this allows you to calibrate, set those zeros that we talked about, all that stuff. If you get into a situation, I always like to check it, but for the most part, it's usually the zeros are already set, just kind of by default. But I always like to check it because another member may have gotten in here and changed stuff, and we want to make sure that it's back to normal. What I'm going to do is I'm going to hit initialize machine. Let me start over. If you get in here and it says connect to cutter, it won't let you do anything because it's not seeing a cutter. If I say connect to cutter, it says there's not a cutter found. It's because the button, the blue button right there on the front, go ahead and push that on. The silver button, sorry. Yep, press it. There you go, and it lights up blue. Now it's on, and the USB is connected to here. So I'm going to say connect to cutter. You'll see it. Now it's good to go. You've got two options here, load new file or initialize machine. No matter what, it always wants you to initialize the machine. When I hit initialize machine, it's going to find its home, not zero, it gets confusing, but its home is the top right hand corner. And it's going to work its way around. So it found the top right corner, it brought the machine to the front, and now it's saying change my tool out, please insert a tool. This is something that's defaulted in its memory, and it does it every time. When I go to do this, let me take this off so you can see it. It's going to automatically want, it's going to automatically want to measure the tool. So it says tool change required. Normally I would go in here and do this. This is a great time for me to show you how to change the tool. You have two wrenches here, small one and a big one. There is a little nut at the top for the small one, and a big one at the bottom. When I go to loosen these up, this bit's going to want to come out. These bits come in different sizes. Like we talked about, this is a flat end bit. This is like an end mill. It's got that flat end. We've got bullnose that are rounded in there. This is a 1/4 inch bit. They come in 1/8 inch, 16 inch, all that stuff, right? So just be aware of that. This is the collet that has the 1/4 inch hole in it for a 1/4 inch bit. In this drawer, we have collets that have smaller holes in them for smaller bits. Does that make sense?
So it said bit number 102. Does it say 102 on the bit? No.
No.
Okay.
Unfortunately, it doesn't.
All right.
But there is a description. They have, if you buy bits directly from Carbide Create, they're numbered and they have little holders. And I couldn't get anybody to use the holders, so they're always different.
Okay.
So just measure it, make sure it fits. So the base of the bit goes into the collet like that, and then this whole thing is held in by this little nut that screws into the into the router. So that basically goes up. There is a little button right here. If you realize that you're trying to tighten it up but it's spinning the thing, you can push this button in and it locks it in place so that you can get the bit started.
Basically, what is that?
There's a 1/4 inch, the largest collet that it will take.
Yes. Yeah. We could get other size collets, but we pretty much do 1/4 inch down to, I think we've got some small, no, most of ours are 1/8 inch. But they do have bits that are 1/8 inch collets, but a 16th inch actual tapered bit. Yeah. So I hand tightened it up with this little lock, and now I'm not gonna wrench down on it. All I'm gonna do is take these 2 wrenches again, find it, and then I'm just gonna snug it up. Just pretty tight, but not over tight because they'll strip out pretty easy. And then you'll see that it's in there good. Now notice that I didn't really care how deep or how long I put it in there, how much I'm sticking out, right? I'm getting it to where there's enough grip on there, it's holding it in good. And it's pretty far in there. But the reason I'm not really super concerned is because now that I've told it I've changed it, I'm gonna say, it says please insert a tool. I've inserted a tool. I'm gonna hit resume. Watch your arm right there, I just don't want it to pinch you. I'm gonna hit resume. What it's going to do is it's going to go over and it's going to measure the length of the bit automatically. Because when you change that bit out, you may put it all the way up in there, you may just barely put it in there. It may be a 2-inch bit, it may be a 1-inch bit, it may be a 3-inch bit. So rather than remeasuring it every time and calibrating everything every time, it does it automatically by going down and hitting that button. It's going to send it back to the center so you can access it. Have a little bit of a gap.
Otherwise, you'll get a lot of channel.
That's good. That's good to know. Yeah. Did y'all hear that? You just don't you don't want to shove it all the way up there where it's bottomed out. Okay. Another side of the carbide motion is just simply being able to control it. And I like this because it kind of gives you an idea of that X, Y, Z coordinate thing that we talked about. I'm going to go to quick actions, and I'm going to say, you know what? I'm just going to do this. Let's do this. Probably easier to do this. So up the top right hand corner, you've got some options here: run, jog. You've got MDI and settings. I'm going to go to jog. I don't want to measure it. I would just measure the tool. I don't want to measure it again. So I'm going to hit, it just asked me, do you want to measure the tool again? No. All right. So Y position. Y. If I hit Y this way and this way, let's see. Let me do this. That's all right. Because of how precise this thing is, and you want it to be really super close there to being precise, you can change the increments of movement. So if I say I want to bump it up and hit, one step in the Y direction, the Y that way, I can do it in 0.001 inches at a time. Now that's going to take forever for me to do that, right? I can change that increment to do 0.01 inch at a time. And so you can't even really still see it. It's moving, but it's right. I can do it 0.1, right? Or I can do it fast. Fast is just, it's not real fast, but it's that fast. You've got to be careful because if I go too crazy with it, I just keep hitting this, right? There's a potential that it could get out of sync and it could run into something or it could, break a bit or something like that. So at that point, when you get, like, for instance, if I say, look, I want to set my zeros. We talked about in the classroom, we're telling it that our zero in the software is the lower left-hand corner, the very lower left-hand corner. So now we have to tell the machine that it's expecting zero to be the lower left-hand corner. So the way we do that is we want to set the zeros. So I'm going to jog it over all the way to the lower left-hand corner. I created this little jig and screwed it in so that this, I even wrote on here, zero reference. This little corner here is zero, according to the machine. I'm going to check that by running it over. You guys can help me kind of line it up here in a second. I'm moving the Y now this way, so I'm going X over this way and Y over this way. And now Z, which way is Z? Z is up and down, right? So I'm gonna go Z. Now, look how fast it's moving. That really scares me because I'm afraid I'm gonna just break a bit, right? So I'm gonna get it kind of close. I'm just gonna tap it, get it kind of close. And then I'm gonna hit increment back down, and I'm gonna do increment to 0.01. Or let's go 0.1. And I'm gonna hit Z down, Z down, Z down, Z down, Z down, right? Now I can go increment 0.01, Z down, Z down, Z down, Z down, right? So what I'm doing is I want to tell it where Y and Z0 needs to be. I'm sorry, Y and X. So right now I'm way off, right? I'm down here. So I'm gonna take it, I'm gonna go, let's go Y this way a little bit.
Just clicking and holding.
Yeah, I'm just holding it and
Okay.
it's doing it in increments.
Okay.
That's set to 0.01. I'm gonna change to 0.1. I'm gonna do this way. Tell me when I'm close. Am I over the hole, over the little? Or do I need to keep going? Go that way? Not like that. Just a little bit. And if you say I go too much, I can change the increments. A little more. Too much.
You're good.
I like that. Okay. And then what about my Y up and down? It's pretty close, right? If I want to get closer to this, I can bring the Z down, so it's a little bit easier to look at and align. And I say, okay, it looks good. That looks like that is my 0 point, right? So now I've determined that's my 0 point. I can go here to where it says set zeros. Now, I'm telling you this, you don't have to do this every time. It should be defaulted this way when you guys walk into the place. As long as your software matches the settings, you're good.
Is there any way to quickly tell if it is?
Great question.
All right.
And that's what I was going to show you. So what I do is I come in and I go, hey, before I cut, I just need to make sure that it's close and nobody's jacked with it. If you look at the position over here, see the X and the Y position and the Z position? These should be, if I'm over the hole and I'm in the right spot, these should be pretty much 0. And right now it says my X position is 0.016. It's pretty darn close. My Y is at 0.008. Pretty darn close. So you guys have a really good eye. You got right dead on, right? But if it was a little bit off and I wanted to set it, then I would go to set 0. And it gives me, it says, which one do you want to set? 0 to. It knows where the position is now. We currently have it set to 0. We say, well, we're only doing X and Y because Z is up and down, and that's not right for Z, right? So let's just 0 out the X and 0 out the Y. And then I'm going to hit done. And now you look at it, 0.000, and the Y is 0.000. That's now considered X and Y is to 0. Now you notice Z is not. Because I don't want a 0 to this, because this is just my little guide, right? I want a 0 to the bed, right? So what I'm gonna do is I'm gonna change it to speed, to fast. I'm gonna move it over so I can see it. I'm gonna hold it down, I'm just gonna jog it over here.
To an uncut area?
Yeah, to an uncut area. And you go, oh my gosh, this takes too long. Well, I can go rapid position, and it's going to pull up this little chart, and I can say, you know what, I want to bring it to the, let's say the front center, and it'll quickly move it over, right? Now that gets me there a little bit quicker, and now I can get it over the wood piece, so we can find that. Okay. Now here's what we talked about with the hold down versus the tape. I use the tape. So this is the tape that I use. If I set the Z position, let me bump it down without destroying the bit here. Slow it down a little bit. Okay, so if I set the Z position to that, Well, all the way. Let's get it touched. Right, all the way down. Let's say that that's all the way down. I don't want to do it yet, but if I say that's all the way down to 0 and it's touching the bed, right? Now I take my piece of wood and I set it down on here, but I'm using double sticky tape. That this double sticky tape might be 0.02 or whatever, right? That's not going to be 0 anymore. It's going to be up a little bit higher, right? Does that make sense? So what I like to do is I like to take the piece of tape and stick it kind of down here like this, maybe even like this. And I'll actually run it down. It's kind of a two-handed job here. And I'll just do this. I'm going to move it back and forth until I can't move the piece of tape anymore. It's starting to drag right there. Now it's really starting to drag. I'm going to hit it one more time. Now I can't pull the tape out. Right? But if I did, there's still a gap there. It's the thickness of the tape now. Does that give you an idea of it? That's 0 referencing with the tape in mind.
It's like bed leveling an Ender 3.
Exactly. It's like that level of 3. What's interesting is that my Z now is showing that it's 0.538 down below what the old Z was set at. And that
Half an
might be
inch.
because somebody's using a different method for that. But I want to set the Z 0 now. So I'm going to set 0. And I'm going to go to 0 the Z. And I'm going to hit that. And now it's going to put it at 0 at 0.0000. And I'm going to hit done. Now all my X, Y, and my Z is at 0. So it knows now. Now, if you bring your software in, your file in, and you've got it set to say 0 is not at the bed, but it's at the top of your piece, it's going to drill down into the bed. Does that make sense? And that's what happened there. So just be aware of that. All right, I'm going to move this out of the way. I'm going to hit Z up. Get it up out of the way. This is the retract height we talked about. This is how high it's going to go up when it's not being used. Now, I'm going to go to rapid position. I'm going to get it out of the way. So I'm just going to say go to the back here. Get out of the way. And now I'll show you how to put a piece down. Here's the piece we were designing. Y'all remember the size? 7 by 8 and 4. 7 by 8 and 4. All right, remember that. So what we'll do is, now that we've zeroed all that out and everything's good, let's go with the creation software. I'm going to recreate it real quick since we didn't. I'm going to go to Carbide Create, open that up. Settings. I'm going to change it to 7 by, y'all said 8.25. Is that the thickness? 0.832. Wow. I'm impressed. 0.832. Got it. Zero's all automatically top, probably because Thomas has been in here, got stuff at the top. I'm going to hit bottom. So just like we did in the classroom. 0.832 thickness, 0 to the bottom, and now set it to the toolpath as lower left for X and Y, right? We set it to hardwood, it's set to a Shapeoko 4, which is all defaulted there. I've got the retract height to set to 1/2 inch, so it's going to come up 1/2 inch off the board, which should be fine. And I've got my units set to inches instead of millimeters. I'm going to hit OK. I'm going to bring a shape in. What do? We just want to do something, doesn't really matter. Bring that in. I'm going to call this 4 inches by 6. Oh, something we didn't talk about. If I'm doing a shape like this, a basic shape, it does give me some options for my corners. I can square off the corners, or I can make dramatic changes in the corners, and let's do a little fillet. Hamper. So I can change the shapes of these, right? Little dog foot thing, dog bone, is that what it's called, dog bone? And then I can change the radius of those curves. So for instance, if we go back to the little rounded piece here, it's set to 0.25 round, I can do 0.5. It's gonna be more dramatic, right? Let's just stick with that for now, that'll be fun. Actually, no, let's do the dog bone. That's kind of fun. Oh, and there's a tree. I don't know what tree is. Doesn't look like a tree. Oh, it says T. I'm sorry. See, I'm freaking blind.
Here you go, Scott.
Yeah, I know. Dude, I'm there. I just turned 50. This has hit me. It's
Yeah.
like it's affected me. All right. So, and then one thing we're gonna do is go back. And I'm just gonna center it on, align it onto the piece again, like we did. So now it's centered on our board. All that stuff. All right. We're gonna highlight it like we did, and we're gonna go to toolpaths. Now we gotta tell it what do we want to cut it out to be shaped like, right? Let's say contour. Let's do. You want to cut all the way through it?
Nah.
Probably not. That's a pretty nice piece of wood. Let's just cut out the shape. We're going to cut it on the inside so that we keep our measurement correct. But let's only cut it down 0.118. Let's see, don't close the tabs. 0.126.
So will it do all of that in one pass, or does it figure out multiple passes?
It'll do it in a continuous pass, but in all one continuous pass, but it will do multiple trips.
Okay.
And I'll show you.
Okay.
So if I highlight the actual toolpath, it's going to say starting depth is at the top of the piece. So I use stock top, right? That's where we want it to measure down from. And then maximum depth, 0.126, or I could, if I want to cut all the way through, I'd hit stock bottom, go all the way through. We're only going down 1.126. Offset direction, and we're going to go on the inside so that it remains the same size we want it to. And then if I was to want to change that, what we're talking about, how far it goes down initially, then I would edit my bit. See, because of the bit that's in default here, the 1/8 inch bit, let's change it to 1/4 inch anyway because that's what we loaded. I don't want to change tools yet. Let's go. The 1/4 inch one is called 201 in mil. I'm gonna select that one. So, couple of things you can change within the bit. I recommend using default. They're always pretty solid. But if you realize that it wasn't cut the way you want it to, you can make some modification. This is where you get kind of really into the nerd stuff. And there's lots of YouTube videos, and we can do a second class or whatever. But one thing is step over. So step over is when the bit comes down to the line and it cuts and makes a path. How far over does it go before it makes the next path? Think about mowing your lawn, right? How much is your step over when you're mowing your lawn so that you get a nice even cut, right? That's what you're figuring out there. Depth per pass, that's what you're talking about. So every pass, you want to determine what's best for that bit, because if I'm trying to cut too much away at one time, it's going to heat up that bit and it's going to really ruin that bit.
Yeah, so what's it saying for this?
So right now it
default?
says it's at 0.04.
Okay.
So our overall depth is 0.126.
That's going to be 33 passes.
Yeah.
233,
Right. So that's what they default for that. They say, hey, this is the best to keep the bit cool, to keep it sharp, all that stuff. Plunge rate is per minute. So speeds and feeds, this is where you get into the nerdy stuff. Plunge rate is how fast does it go down into the wood. Again, that's important, like how you know, dulling a bit. The feed rate, how fast does it move across, right? It's at 60. I don't even know what that is. 60 per minute. So I don't know if that's. It's not going to be. Would it be inches? 60 inches per minute. Yeah. Since we're set to inches. And then RPM. That's how fast the speed is on the router. It's set to 18,000. It will convert it to actual numbers on the hand routers that we've got in here, and it'll say set it to 2, or set it to 3, or set it to 4. But if we were to put the really high-end pieces on there that are water-cooled and everything, it'll automatically control that. We manually turn things on and off just for safety reasons. We're going to hit OK. All right, so let's go preview it real quick. Show simulation. I'm going to select. It's set to aluminum just to preview. It's only a graphic image. I'm going to set it to cherry. Let's set it to MDF just so you can kind of see the difference because we did cherry. So this is showing it on an MDF piece of wood, right? So basically that's what it's going to look like. If you were to zoom in on it, the green lines are showing the actual path. So like if you were to zoom in on it, then you would see the actual layer after layer that it's going to cut. I could turn those off, then you won't see those. But that's basically the shape that it's going to carve out. Any questions on any of that? Again, really basic cut. You can get super complex with it. If we were to pocket this out, it would obviously do exactly that, but all the stuff in the middle would be gone. It would take a while to do that. You guys are welcome to hang out and watch it if you want, but I'm going to go home.
You're not supposed to leave a project once you start it.
That's true. So I'll let you guys start it. So once you say, okay, this is great, I love this is really pretty or whatever, then you're like, okay, good. I'm going to save the file like we did in there. Save as. I'm going to just save it to the, let's save it to the desktop. It doesn't matter. This is only the preview, so it's just giving you a graphic overlay. It's not the material that's used. It's a little bit confusing. Let's call this CNC class. When you hit save, it's on the desktop now. Just save the file. Okay, now, that's what we did in here. Normally I would have just transferred that to the G drive and gone to the G drive and pulled that off and opened it up. We're going to close out of the create software. We're done with creating the. Now we're going to open up the motion, which is what we use to set everything up. I'm going to hit load new file. In this case, I'm going to go to the desktop because that's where I saved it. Normally you go to the Google Drive wherever you saved it. And I'm going to select my file. CNC class and hit open. It's going to load that file into the machine now. First thing I do is I check to make sure everything looks right because it's going to tell you that your stock size is 7 inches wide by 8 1/4 inches tall by 0.83 inches thick. And I verify, hey, that's our piece. It's going to say the only tool that we're using today is the tool number 201, which is the 1/4 inch bit. It's going to say that it's going to take us 2 minutes to do this cut, which puts me home for dinner. So across the top, we've got these tabs: the top view, front view, ISO view, and the actual G code. If you really want to nerd out, this is the code that it takes to do that simple cut. There's a lot of lines of code. There's 1,941 lines of code.
I'll put that on now.
You can do that. That's because, like I said, it's telling you, or you're telling it, X 1.5636Y, right? Or X 1.5636 over this way. Y 1.206 this way, and point F60. I don't know if that. Oh, that's some kind of speed and beat thing. But anyway, those are the coordinates we talked about in the class meeting. It's doing that line by line. All right. We say, hey, that looks good. I read G code like Don, and I know exactly what this says. So I'm going to hit done. Now it's ready to cut. Okay. Part of that G code automatically is telling it the bit size that you loaded in the file. So when you created it, you said, I want to use a 1/4 inch bit. So it's annoying, but it's going to say, when I go to hit start job and go, it's going to say change the bit, even though the bit's already in there, but we're just going to play along. So once you're back there, oh, I guess we should put our piece of equipment there, right? Put our wood there. Okay. I used the tape, but since we're not cutting all the way through, I'm not too concerned. So instead of dealing with the tape, I'm just going to show you how to. Tape's easy, right? You guys know how to use double sticky tape. Tape on one side, peel off the thing, stick it down. These are the clamps. So these clamps, these hold down clamps, they're in here. There's a variety of shapes and sizes, right? They can be confusing. You can hold them, you can set these up to hold the piece down flat like this, but if you notice, if I'm cutting around here and I've only got 1/2 inch set as my retract height, I could damage this. The bit could come across here and hit this, right? So I would, if I had to do this, I would change my retract height higher, right? Or these are shaped, we 3D printed these. These are shaped so that this little lip, this real low profile hold down, right? So you just flip them over, put that there. You can also flip them this way, and you can use it to kind of sandwich pieces in. And I'll show you. These are cool because these will hold down, and then they have a little adjustment screw that pushes out, so applies pressure as you tighten it down. These are cool. These, the little nut goes in there, and then if this is fixed down to the piece, it's fixed down to the piece, put it like that. As you tighten it this way, it basically sandwiches in there. It just presses it and holds it in place. So we got some options. I like these. All of the little nuts and bolts are in here. All of the little tools to tighten this stuff down needs to stay in here, along with a variety of your bits. Keep in mind, I've got a lot of scrapes and cuts because I'll reach into this thing and all these bits are sticking out. So just keep that in mind. Probably should come up with a better idea for that. But these are the little slides, the little aluminum pieces that are fit within the track. So, I'll show you what that looks like. The little aluminum piece slides into the track. This fits down onto the track. The nut goes in there. It gives you the ability to move this stuff around, slide it back and forth, twist things around. Does that make sense? And y'all are free to play with all this stuff before you actually make any cuts. All right, I got two over here already. I'm going to grab the wrench. Little Allen. There's also this little handle piece. So what I'm doing, I'm using this as my zero, right? I'm using this as my kind of template. I'm going to wedge this up against here. And then what I like to do is keep it kind of low profile. I'll put my hold down kind of center here, and then I'll tighten it up. And what I'm trying to do is keep it from sliding around, right? Because it's not going to be accurate if it moves around. The other thing that's a good idea, doesn't really happen very often. With acrylic it happens quite a bit, but with wood it doesn't seem to, is as it's spinning and drilling, it's going to want to pull the piece up, right? So just be aware of that. So it's nice to have some kind of hold down. I'm going to slide this over here. Just kind of wedge that in. And now that piece is not going to go anywhere, right? Again, this double sticky tape works great too. It is kind of a pain to get up because once you try to peel it off, you got to peel off the tape and all that stuff. But it's not bad. I like it because you don't have other pieces of plastic and metal on the machine. Okay. What's that? Yes. Okay. So when this thing is running, it creates a lot of dust. So we have a dust collection system. The dust collection system automatically comes on when you power on the router. We don't have it set up to automatically power on the router because in my mind that's dangerous. If I hit go on the computer or if the computer decides to go and my hands are in there, there's potential to be an issue. So I've got it set up so that it says start the router and you turn on the router manually. That being said, the dust collection. The dust collection, you got a couple options. These are magnetic, and you've got the brush set up, which really works best, but sometimes the brush gets in the way. There's a low profile piece that is interchangeable with this one. So it's just magnet, right? So now no brush, low profile. That's for smaller pieces. You want to get in there, you can do that. If you've got pretty big stuff that you're working a lot of dust, this is great to keep dust out. Let's do this so you can see the bit work. So this thing has a little clamp that tightens on it. All I'm going to do is I'm just going to slide it up and clamp it down. The bit's out the bottom there, so we know we got a little bit of room. One thing to be aware of, I'm going to move it up a little bit so we can get good job. That position. All I did was just rapid position it to the center so we get to it. Okay, so one thing to keep in mind, if I've got this all the way up and it's locked in place, and I measure this and I say, look, this bit is sticking 1.5 inches down, right? But my stock material is 2 inches, and I'm trying to cut all the way through it. What's going to happen? It's going to bottom out, right? This is going to drag. Another thing to think of when you're cutting out through stuff, especially big pieces, is that how much room do I have? In that case, you probably just want to remove it all together and just sweep up after you're done, or vacuum after you're done. But if it's something like this and we're just engraving a little bit, and we're not going very deep, I'll do this, and then this dust collection hose just slides right on top, like that. The reason that it's loose is a lot of times, after it's done, people will pull this up and vacuum with it, right? The downside to that is that if this vacuum is on, this bit is spinning. So if you're vacuuming, and I've done it lots of times where I'm vacuuming, it'll nick you. So just be aware. We do have the roll around shop vacs. I would much rather see you do that than try to do all that. Anyway. Okay. All right. Dust collection's on. We're good there. I'm gonna hit done. I'm gonna go back to run where we were at. We loaded the file. I'm gonna hit start job. When I hit start job, it's gonna bring me to this. So this is the run job page. It's gonna tell you the lines that it's on, the lines of G code that it's on. Right now we're on 0 because it hadn't started, but it's got 1,942 lines to go, right? There's also a progress. If you don't want to count the lines, there's a progress, 100% done, 50% done, that kind of thing. And then time remaining. Right now it's under 1 minute. Over here on the right, you see feed rate. You can plus 10%. You can add 10% feed rate. The only time that I do this is if it's a very, very basic cut. If I'm cutting straight lines or circles and it's taking too long, then I could bump up this feed rate to make it go faster. It's going to cut a little bit faster. If it's complex or if it's hardwoods that you're really not sure about, you don't necessarily want to mess with that because again, you'll start to heat up the bit. You're trying to get more out of the bit than it really is made for. So you can plus 10% or negative 10%. You can increase or reduce 10%, or you can reset the feed rate back to the G code setting, the original setting. That's what that is. And then the start button. Now when I hit start, it's going to start on the very first line of code in G code. It's going to start here. Actually, it's already the 11th line. So 11th line of code says, make sure there is a 1/4 inch end mill stuck in the machine. So add that. Well, we already did that, so I'm not going to do that now. I'm going to hit resume. What's it going to do? It's going to go measure that again because in the G code it says make sure you measure it. Sometimes it's annoying because you're like, we already did this, but it's just it is what it is, and it really is a good safety measure to make sure that it's always accurate.
The laser can do this.
You're absolutely right. Yes, that is a great point. All right, so now it's going to go back to center. Now it's going to say, hey, if everything you did, Scott, is right, then we're going to begin, and it's going to be right. But there's a good chance that I screwed something up. It's going to say, change the spindle, the router RPM, set speed dial to 3. And basically this is telling you to turn it on. We manually turn it on for safety reasons. You can set it up to automatically turn it on. We're not doing that. So I'm going to set the little dial at the top. It says it's set to 18,000 RPM, and it says 18,000 is the number 3 on this router. So I'm going to set it to 3. I know there's a lot of talking going on, but the fact is it really steps you through all this, and it's gonna remind you, hey, do this, do this, do this, do this. And it's all gonna come back to you. You don't have to remember all this. So set it to 3 and turn it on. It's gonna get loud, but when I turn it on, the vacuum should turn on, and that bit's spinning and dangerous at this point. It's good to go. I'm gonna hit resume. It's gonna go to my first line of code. Start cutting. these are all just little, because of the type of wood we're using and the bit's kind of dull, it's going to leave these little flakes. Normally what we'll do is run this through and just hit it with a sandpaper and take these little pieces off. That's actually a pretty bad cut. I got to check that bit. It's a pretty dull bit. Yeah, it's a dull bit. But you kind of get the idea.
If somebody were going to buy their own bits, where would you suggest they get their own bits?
I would do it online.
From-
Carbide 3D, go to their website. They've got all the, that way you know the settings are going to match. If you go to Amazon and buy bits, all the bits from Amazon will have the settings, the recommended settings on them. You have to manually enter those in there. So you'd go to create a new bit and then put those settings in there and then title it Amazon bit or whatever you're going to call it, right? Any questions on that? I mean, it's not a very cool, finished product, but you get the idea, right? Just for time reasons. One little bonus thing I'll show you. I'm going to jump back over to the design software real quick now that we've got it set up.